What is energy, and how does energy make everyday activities possible? So first of all, there are many different forms of energy. We will be talking about some of them in this video and go in more detail in other videos to follow. So energy is the ability to do work or cause a change. So when you are running, you are using energy. You are working, you are doing something. Energy cannot be created or destroyed. I want to show you a video in the beginning here, and I want you to think about what Bill Nye, this is a Bill Nye video, tells you as my video continues.
We're just going to go rock and roll. Right now, this bowling ball has energy. It's not moving, but it's got energy. Please consider to follow. You ready? 3, 2, 1.
So think about that video and the vocabulary words that Bill Nye used as I explain them. Remember from the video, energy cannot be created or destroyed, but it can move from one object to another. It also can change from one form to another. So when Bill Nye held the bowling ball up, the bowling ball had potential energy. When he let it go, that potential energy changed to kinetic energy into a different form. So other devices that can change or transform energy are lamps. Lamps change electrical energy into light energy in the light bulb. An engine in a car changes many different forms of energy into other forms of energy. One example is kind of like a lamp using electrical energy from the battery turning on the headlights of the car, so changing electrical energy into light energy again. Another example would be changing the electrical energy from the battery into sound energy as you hear the radio. There are a lot of different examples of transforming energy from one form to another. So kinetic energy. Kinetic energy is energy due to motion, and it depends on speed and mass. So the more mass an object has, the more kinetic energy it has. Kinetic energy can also change to thermal energy, so an increase in thermal energy results in an increase in temperature. That also has to do with speed. If a bowling ball is rolling down the hill and it's going very fast, that will increase the thermal energy and the temperature will be increased pretty high. Potential energy is energy that is not causing any changes now, but could cause changes in the future. Are you sitting right now? You have potential energy. You have the potential to get up and walk to the kitchen to get a snack. The bowling ball in the video was being held by Bill Nye had potential energy. It's stored energy. Here, in this example, when the roller coaster is at the top of the hill, stopped, ready to go, it has potential energy. It changes to kinetic as it goes down the hill. Some other forms of energy are chemical energy. Chemical energy is the energy of electrons that form the bonds between atoms in molecules. So when fuel is burned in a car, in a furnace, or a power plant, chemical energy is changed. Heat and light are produced. The fuel for your body is food. Some foods give you more energy than others, and chemical changes happen in your digestive system to create that energy. Now, another form of energy is nuclear energy. Nuclear energy holds the protons in the nucleus. You know that from our study of atoms. So when something knocks the proton out of the nucleus, nuclear energy is released. Nuclear power plants are places where this happens, and it is a very extreme reaction and has to be controlled extremely well. That's why they do this in power plants and in controlled situations. I know this video is going to be a little bit long, but this is an important topic for you to understand. We are going to be doing a project in class about kinetic and potential energy. We will also be going more in depth about sound energy, light energy, and thermal energy. But I'd like to just show this quick video. You don't necessarily have to remember a lot of the vocabulary towards the end of the video, but the beginning of the video is the most important part.
So, what is energy anyway?
Feeling tired? Lacking that spring in your step like a tortoise after Thanksgiving dinner? Shake off the blahs with Enerva tea. Now with 500% of your daily recommended energy. The other guys only dump caffeine and sugar into their pick-me-up drinks, but Enerva tea uses only 100% pure energy harvested from the drums of pink bunnies. Buy some today. Do it. Go. Stop listening to me. Go to the store. Get off your butt and go out there. Get in the car, take the bus, get on a bike, whatever it takes. Enerva tea. It will help you. It will help you. It helps me.
If it moves, lights up, heats up, melts, breaks into pieces, or burns, it's powered by energy.
Energy is what moves particles around, like in a gas or a liquid. Particles in a solid stay in one place because they don't have enough energy to go somewhere else. Basically, energy is motion.
You can't usually see energy. So how do we know it's there? Try temperature. Temperature is a measure of the motion of particles in a substance.
When particles move quickly, things warm up fast. Hello high temperature and hello energy.
The particles in cold things are low energy. Lower energy means lower temperatures because particles don't move as much.
So how do cold things get warmer? One word: heat. Heat is a transfer of energy. Cold things have way less energy than hot things. So when the two things touch, energy jumps over from the hot side to the cold side until they're the same temperature. That transfer is what we call heat.
When heat is transferred from something warm to something cold, the cold molecules gain energy and warm up. The warm molecules lose some energy and get cooler.
When energy moves around, it can take one of two forms: potential energy and kinetic energy.
Potential energy is the energy something has before it moves or does work. It's energy, ready and waiting to attack. Before this spider monkey jumps on the head of a passing rhino, it has potential energy.
Potential energy can take lots of different forms. A baseball has potential energy at the top of a pitcher's windup. A match that hasn't been struck has potential energy. A roller coaster at the top of the hill has potential energy. Anytime energy is being stored for motion or work, there's potential energy.
After potential energy comes kinetic energy. Kinetic energy is the energy of motion or work. Now the spider monkey has kinetic energy instead of potential energy. Now, potential and kinetic energy go hand in hand. You'll learn more about this in a minute, but there's only a certain amount of energy out there, and it can change forms anytime. In this case, the energy of the spider monkey turned from potential to kinetic energy.
Energy is everywhere! So how do we keep track of it?
Energy is always measured in systems. A system makes it sound all complicated, but it's really just an area where we want to keep track of energy. When something loses energy and something else gains energy, that's a system. Everything outside a system is called the system surrounding.
Remember, when it comes to energy, there are two kinds of reactions, exothermic and endothermic.
Exothermic reactions give off energy. In other words, energy moves from the system into its surroundings. Sometimes that takes the form of heat. Any reaction that warms up is an exothermic reaction.
Exo is Greek for out, or outside. So you know an exothermic reaction is a reaction where heat moves out of the reaction. Think exclaim, expand, explode.
So where does the energy in an exothermic reaction come from? It's all about potential energy. In a chemical reaction, the reactants have more potential energy than the products. They're just waiting to react. After the reaction, all that energy has nowhere to go, so it's released into the system surroundings. Voila! Heat! Endothermic reactions are the opposite of exothermic reactions. They pull energy in from their surroundings. Any reaction that turns cold is an endothermic reaction.
Endo is Greek for into or inside, so an endothermic reaction is one where energy goes into the reaction. Think endo for into.
We keep track of energy changes in chemical systems by using a number with two parts, magnitude and sign.
Magnitude is just a fancy word for how big a number is. A big number means a big change in energy, and a small number means a small change in energy.
The sign before the number tells us whether the reaction gained energy or lost energy, but it's always from the point of view of the system. If the system gains energy like it does in endothermic reaction, the number is positive. If the system loses energy like it does in an exothermic reaction, the number is negative.
Just remember, if a reaction changes directions, the sign in front of the heat of reaction also has to change.
So, what is energy anyway?
Feeling tired? Lacking that spring in your step like a tortoise after Thanksgiving dinner? Shake.
So that was a lot of information, and we will be, like I said, researching and doing our own projects on energy, your choice. Remember to rewind if you need to and rewatch and fill out your notes completely.